Okay, question 4.3. Now this question is worth 8 marks, so there's a couple of parts and it's a little bit challenging. Let's try this. Prove that for any angle, all of this stuff here is equal to the root 6 minus root 2 over 2. Ooh, okay. So first I got to simplify this whole side here. Somehow I got to do that. So let's look at this. Oh, I've got sine 2a. The easiest marks there is substituting sine 2a with 2 sine a cos a. Well, this is 4 sine a cos a. If I make 4 2 times 2, then look, that 2 sine a cos a is going to cancel. Now, in the top, I don't know about cos 2a, but I know that the tangent of 225 degrees, it's in the third quadrant. The reference angle is 45 degrees, and it's the same as the tangent of 45 degrees, which is 1. And 1 minus 2 sine squared, well, that's equal to the cosine of a double angle of 2a. And that's on our formula sheet. So I can rub out 1 minus 2 sine squared a and put cosine 2a, and they'll cancel. When I did this, I rubbed out cos 2a and put the longer thing, but it amounts to the same thing. Look at all this stuff. It's going to cancel anything divided by itself. And I'm just left with 2 sine 15 degrees. And now I'm thinking about this 15 degrees. How can I figure this out without a calculator? Oh, there's that trick. Instead of 15 degrees, it's 45 degrees minus 30 degrees. Now I'm missing something here. If I don't put down for the next part, you've got a formula sheet that says the sine of the difference of two angles is equal to the sine times the cosine of those angles minus the cosine times the sine. You keep the sine the same. And that's all written out. Now, what I have to do now is I have to change this into, or what I have to do is I need a right triangle here. I'm missing something here. I would have to, because I'm going to use the cosine of 45 degrees, I have to draw 1, 1, put a root 2 there, and 45 degrees to show that I can do this without a calculator. So the sine of 45 degrees is really 1 over root 2. You've got to make these special triangles here. And the cosine of 45 degrees is really 1 over root 2. And then you've got to make another triangle. Maybe I'll make it a little bit longer like this. And you got to put 60 degrees and 30 degrees and go 1, 2, root 3. And then show that the cosine of 30 degrees, you've got 30 degrees up here, it equals what? It equals, you've got on the long side, you have root 3. And it equals 2 over root 3. 2 over root 3. That's the cosine of 30 degrees. Yeah, that's right here. Oh, adjacent. 2 over this long side, that'll be root 3. And the sine of 30 degrees, ooh, that's an easier one. The sine of 30 degrees is the 1 over root 3. That's 1, 2, root 3. It's 1 over root 3. So you have to have your special triangles all filled in so you can fill out these fractions. And then you just start doing some stuff like, oh, 2 root 2 is in the bottom here. This is one way of doing it. I'm multiplying 2 up here. Hey, those 2's cancel. It looks like I've just got root 3 minus 1 over root 2. Hey, but you're not allowed to leave a root 2 in the bottom. We're going to rationalize it. So we're going to multiply root 2 by root 2 and the top by root 2. And something really good's going to happen because root 2 times root 3 is root 6. Oh, that's what we want. And root 2 times minus 1, oh, that's minus root 2. And root 2 times root 2 is 2. So we've just proved that all this stuff reduces down to root 6 minus root 2 over 2. But you have to have your special triangle showing that you can do this without a calculator. You know, if you press sine 45 in your calculator, you get root 2 over 2. You need to show you've done it without a calculator. So there's that question, all done.